Hello students, today let us solve the problem related to the atomic structure. The question is given, ionization potential of hydrogen atom is 13.6 electron volt. Hydrogen atom in the ground state are excited by monochromatic radiation of photon energy 12.1 electron volt. The spectral lines emitted by hydrogen atoms according to Bohr's theory will be. 4 options are given. So, here what are the given data? The ionization potential of hydrogen atom is given, that is 13.6 electron volt. Ionization potential is nothing but, or we can also say it as ionization energy. It is the energy required to remove an electron from an isolated atom, or we can say that it is the energy required to remove an electron from its lowest energy state, where the electron is completely free. Okay, so this is the ionization energy, the energy required to remove an electron from the atom, that is where the electron is completely free from the atom. Okay, and here energy is given, that energy is 13.6 electron volt, and also photon energy is given, that is emitted by the monochromatic radiation, so that is 12.1 electron volt. Using the Bohr's model, we know that En is equal to minus 13.6 divided by n square. If you remember the energy levels diagram, that is n is equal to 1, n is equal to 2, n is equal to 3, so on. For the lowest energy state, that is n is equal to 1, so the energy is minus 13.6 eV, and for the next n is equal to 2, it is minus 3.4 eV, and when n is equal to 3, the energy is minus 1.51 eV, so on. So now for the hydrogen atom, here it is given the energy is, the ionization potential of the hydrogen atom is 13.6 electron volt, means it is in the ground state, n is equal to 1. So to calculate the number of spectral lines, the total energy, let's take E is equal to ionization energy, that is the final energy E is equal to minus 13.6 plus 12.1 electron volt. So the final energy E is equal to minus 1.51 electron volt. Okay, so here we have to calculate the number of spectral line emitted. To calculate the number of spectral line emitted, we have to know the n value, means in which state the electron is present. So here we can directly say that if you remember the energy level diagram and the energy value, you can directly say that that is minus 1.51 electron volt means it is in the n is equal to 3 state. So, or you can calculate like this also from this equation, that is En is equal to minus 13.6 n square. En is minus 1.51 is equal to minus 13.6 by n square. We have to calculate n value, that is n square is equal to minus 13.6 by minus 1.51. So it is 9, minus minus get cancelled, n square means 9, so n is equal to 3, same, that is n is equal to 3 state. So the number of spectral line emitted is equal to, it is given by the equation n into n minus 1 divided by 2. We know the n value, we have already calculated, that is 3. Now substitute n into n minus 1 by 2, 3 into 3 minus 1 by 2. So this is 3 minus 1, 2, 2 3s are 6, 6 by 2, that is n is equal to 3. So the number of spectral lines emitted is 3, which is the third option. Thank you.